Okay, so we have to do this by integration by parts. Remember, integration by parts is the following: u dv is equal to uv minus v du. Okay, so look, whatever you have in the original question, you have to have it right here too. So look at this question here, and look what we have here. So that right there must be our u. Okay, so if you let u equal to cosine n minus 1 x, right, then dv must be just the extra cosine that's left over. Let's differentiate du. Differentiate, then you get du. You get n minus 1 cosine of n minus 2x chained by the derivative cosine, which is minus sine of x. Okay, and v is going to equal to just sine of x. Okay, so by integration by parts, okay, let me just let this part, the original question, be a. We get the following: sine of x cosine of n minus 1x, okay, minus, because it's this minus right here, I'm going to get plus n minus 1 and sine squared x. Okay, so we have something that looks like what's on the right side, but here on the integral side we only have cosine. Here we have sine and cosine mixed in together in here. So let's change that sine all into cosine, okay, which is not hard to do. So sine is 1 minus, okay, cosine squared x. Okay, so now let's expand, and we get, if you expand that, we get this. Okay, expand one more, and we get integral n minus 1 cosine n minus 2 plus 2. Okay, actually with a negative sign in front, sorry, because this is negative at the front here, to the power of n. Okay, so look, let's bring that to the other side, because if you notice, this is exactly what we started with, right? Integration of cosine to the power of nx. So if you have a on the other side, if you bring this over to the other side, you get a plus n minus 1 a, right? This integral sign and this, that's a. Okay, so we have n minus 1a on the other side. Okay, pull out the n minus 1. Okay, if you combine these two, you get exactly NA. Let's divide both sides by n. Okay, and then we get 1 over n n minus 1 over n integral of cosine n minus 2 x dx. Okay, which is a formula that they wanted us to prove.